Fire. It cooks our food, keeps us warm, gives us light, creates power for transportation and industry. But fire also destroys our factories, ruins our homes, and takes our lives. Today, thanks to fire education and scientific equipment, most fires can be controlled. Here's a large fire being brought under control by a carbon dioxide extinguishing system. This picture will show you how to combat small fires to keep them from becoming serious fires like this. Fires differ. Each has a personality all its own. That's why you have to use the right extinguisher for each fire. This can happen when you select the wrong extinguisher. Here, an expert who makes his living demonstrating firefighting equipment will try to put out a gasoline fire with a water extinguisher. Notice how water spreads this fire. Water is heavier than gasoline, so it can't blanket and smother the fire. Instead, the gasoline floats on top and continues to burn. No first aid water extinguisher will put out this fire. Now, on the same type of fire, let's use the right equipment. A carbon dioxide, foam, or dry chemical extinguisher. Let's try carbon dioxide. That's it. The fire is smothered with a blanket of carbon dioxide. The use of the right equipment is the first step in controlling fires. But firefighting isn't always so simple. You can get into trouble even when you're using the right equipment. Foam is an approved extinguishing agent for burning liquids. Yet, incorrectly applied, foam will fail to put out a fire. The firefighter is much too close, and the force of the extinguisher stream spreads the fire by splashing the flaming liquid out of the tub. When fighting fires in deep liquids, bank the stream against the wall of the container so that the foam can spread across the surface of the fire. With foam, it's important to blanket the burning surface. Whenever possible, let the freeboard principle help you put out the fire. Freeboard is that part of any container above the level of the liquid, whether the container is a tub, quench tank, or dip tank. Watch what happens when the stream from a vaporizing liquid extinguisher is directed against the freeboard of the container. The stream is broken up, and the liquid vaporizes immediately. The vapor quickly spreads across the fire and puts it out. The freeboard also acts as a retaining wall to keep the smothering vapors over the fire. To control fire, man has had to learn its inner secrets. We know that 3 elements must be present to support fire: heat, fuel, and oxygen. If any one of these elements is removed, the fire goes out. When we fight fires, we are simply trying to remove one or more of these elements. Water on a fire removes heat. The heat is used up to turn the water to steam. When the temperature falls below the burning temperature of the fuel, the fire goes out. When we turn off the gas on a stove, we have removed the fuel from the fire. Without fuel, the fire goes out. A cover over a fire keeps air away. The fire chokes to death from lack of oxygen. To show the correct agent for extinguishing each type of fire, the Kidder Company has prepared this chart based on the recommendations of recognized fire protection agencies. Kidde also furnishes identification labels for each type of extinguisher to help prevent mistakes in use. The underwriters' laboratories classify fires under 3 distinct types: A, B, and C. A Class A fire involving paper, wood, cloth, excelsior, rubbish, or any material that leaves glowing embers is best extinguished by the quenching and cooling effect of water, soda acid, or foam. A Class B fire involving burning liquids like gasoline, oil, paints, or cooking fats requires the smothering action of extinguishers using carbon dioxide, dry chemical, foam, or vaporizing liquid. A Class C fire involving electrical equipment like motors, switches, or appliances requires a non-conducting extinguishing agent such as carbon dioxide, dry chemical, or vaporizing liquid. Here's a Class A fire. This is the kind of lattice used by the underwriters' laboratories as a test for water and foam extinguishers. It is the kind of fire you must fight in the walls of a wood frame building. And here's a 2.5-gallon water extinguisher, one of the best answers to the Class A fire problem. Water saturates burning material and prevents rekindling. When you are within range of the fire and not before, turn the extinguisher upside down and bump the top on the ground or floor. The impact releases the propelling gas to force the water out. Start at the top and work down so that the dripping water will help to fight the fire. Wet as much of the surface as possible to knock down the flames. Then go back and attack specific flaming areas. In this way, you make the most of the water supply. When all of the flames are out, go back over the charred areas and quench any smoldering embers to prevent rekindling. Use all of the water and be sure. No one extinguishing agent is best for all types of fires. Foam also is excellent for a Class A fire because it has both smothering and wetting action. The foam extinguisher is inverted just like the water extinguisher. When it is turned upside down, the foam solutions mix to form a gas which forces the foam out of the container. To fight a Class A fire, you use foam just the way you use water. A soda acid extinguisher can be used the same way too. All 3, water, foam, and soda acid, come in similar containers and are applied in the same way on Class A fires. Regardless of which extinguisher you use, make sure the fire is out. Saturate each questionable spot to prevent a rekindled fire. Remember, there's no way to save the fluid in this type of extinguisher, so use it all to make sure the fire is out. Since you must bump the water extinguisher to make it work, it is a good idea to train yourself to bump all 2.5-gallon extinguishers on the ground. It's a rule that will overcome mistakes. Now, let's see a Class B fire, a fire involving burning liquids. When flaming liquids are spilled on the ground or on a floor, it's called a spill fire. For this type of fire, foam, vaporizing liquid, dry chemical, or carbon dioxide may be used. Let's watch a 20-pound dry chemical extinguisher in action on a typical outdoor spill fire. Be sure to pull the locking pin. In using dry chemical, the important thing to remember is to get the chemical into the fire so that it can do its work. Take your time. Make sure the fire is out as you go. Dry chemical absorbs heat and acts as a heat shield for the firefighter. Here's another Class B fire, a burning paint locker. We'll use a 15-pound carbon dioxide extinguisher on the fire because it leaves no residue and will not contaminate the paint. When you are in range, pull the safety pin and remove the horn from the holder on the extinguisher. Simply pull the trigger. Start at the base so that the lower flames will not reignite the flammable material above. Sweep slowly upward to be sure the flame is extinguished on each shelf and in each can before you go to the next shelf. Remember, in most cases, you have only one chance to fight a fire, so put it out the first time. Don't try to economize. Use all the extinguishing agent available. Another kind of Class B fire is called a running fire. This kind of fire might be caused by a ruptured gasoline tank or drums of paint or lacquer thinner. For demonstration purposes, we'll use this perforated pail and drain board and a 15-pound carbon dioxide extinguisher. In fighting a running fire, it is important to start at the farthest edge of the flames and work back to the source of the fire. Kill the fire on the ground first. When the ground fire is completely out, sweep up into the running fire. Take your time and be thorough. Even after the fire is out, play the carbon dioxide over the burned area until the extinguisher is exhausted. This is a common type of running fire. Drums of flammable liquids often have leaky valves, which allow enough fluid to escape to cause serious fires. Again, the 15-pound carbon dioxide extinguisher is selected to stop this blaze. Make sure the ground fire is completely out. Then sweep up into the running fire. Use the rest of the extinguishing agent to cool the leaking valve so that you will be able to turn it off. For a third kind of Class B fire, we will use a pan which is divided into compartments to show the kind of obstacle you might find in a ship's bilge or under a factory walkway. Because of the obstructions, you must use an extinguishing agent which has three-dimensional qualities, such as carbon dioxide or dry chemical. To see why, let's first try foam. Even if the foam is delivered to the fire correctly, the obstructions prevent it from flowing over the surface of the fire. Each compartment must be treated as a separate fire, and there isn't enough foam in the extinguisher to completely cover the burning surface. The best agents to use against this type of fire are carbon dioxide or dry chemical. Unlike foam, carbon dioxide flows over and around the barricades. Thus, all the individual fires can be treated as one big fire. In fighting a fire in compartments with carbon dioxide, slowly sweep the fire ahead of you until you are sure all the fire is out. This is a Class C fire, one involving electrical equipment, in this case, a motor. Vaporizing liquid is an approved agent for extinguishing electrical fires. It is a non-conductor of electricity. In this case, we'll use the 1-quart size. Fires in electric motors can be very difficult to fight, since the motor may be almost entirely enclosed. Whenever possible, direct the stream of vaporizing liquid into the openings. When this liquid makes contact with the fire, it forms a flame-smothering vapor. Be careful not to breathe the fumes, and ventilate well if the fire is in an enclosed space. Dry chemical is also an approved agent for use on electrical fires. It too is a non-conductor of electricity. A 5-pound extinguisher will handle a small fire like this one. It will be necessary to clean the motor after using dry chemical. Carbon dioxide is an excellent extinguishing agent for electrical fires. This is the 5-pound size. Carbon dioxide is a non-conductor of electricity, leaves no residue, and will not damage equipment. The smothering gas completely envelops the motor, preventing oxygen from reaching the fire. Use all the gas remaining in the extinguisher to cool the hot motor housing. You have seen examples of the 3 classes of fires and 5 different extinguishing agents recommended for these fires. A Class A fire involving paper, wood, cloth, or materials that leave glowing embers calls for a water, soda acid, or foam extinguisher. A Class B fire involving burning liquids calls for carbon dioxide, dry chemical, foam, or vaporizing liquid. A Class C fire involving electrical equipment calls for carbon dioxide, dry chemical, or vaporizing liquid. Remember, it's important to select the right kind and size of extinguisher. Have plenty of extinguishing agent available and use it all. Be prepared when it's your turn to fight a fire. It's as simple as ABC. A, always choose the right extinguisher. B, be deliberate. Go slowly. C, completely discharge the extinguisher to be sure the fire is out. These simple ABCs may save your life, your property, or your job.